Hello everyone. In the last two videos, I had taught you the concepts of correlation and regression line, as well as two problems on as to how to find correlation coefficient and regression lines. So we considered two problems. These were the problems which I considered. The first one was this, and I'd considered one more problem, the second one, wherein I had taught you two methods of finding correlation and regression lines. The first method was this. We had implemented this formula to find out the regression lines. And the second method was simpler one, if you remember. This was the formula which I had used. Y is equal to summation xy by summation x square into x. So the difference between these two, I'll mention it again. If at all R is asked first it is asking you to find correlation coefficient and hence find regression lines, then you have to go by first method itself. And if at all he has mentioned find the lines and then find correlation coefficient, then you should go by second method. So if at all it's not mentioned and he has just said find correlation coefficient and regression lines, then it's your choice, and it would be easier if you solve it by the second method, because that's not lengthy and the first method was lengthy, if you remember. Now moving on to the next kind of problem. Okay, we'll go for the next problem. I'll read out the question. In a partially destroyed lab record, only the lines of regression of y on x and x on y are available, as 4x minus 5y plus 33 equals to 0 and 20x minus 9y equals to 107. Calculate the mean of x and y and also find the coefficient of correlation. So what is given here? Two lines are given. The x values and y values are not given here because the lab record is mentioning it's partially destroyed, because of which the initial data has been destroyed. That is, x and y values are not there, but the lines formed from those two x and y values are given there. You have to calculate mean of x, which is x bar, and mean of y, which is y bar, and also find the coefficient of correlation. So now I'll teach you how to find x bar, y bar, and the value of r when the data x and y is not given, but only the lines are given. So the two lines which will satisfy those variables x and y are given, that I've written here: 4x minus 5y plus 33 equals to 0, 20x minus 9y minus 107 equals to 0. And x bar and y bar represent mean of x and y. That means they'll satisfy the given equation. Since x bar and y bar are mean of x and y, they'll satisfy the given equation. Or to tell it in one more way, x bar, y bar always pass through the regression lines. So just replace wherever x is there as x bar and y is there as y bar. So that's what we'll do in the first step. We'll replace wherever x is there as x bar. I've done that. 4x bar minus 5y bar equals to, I'll shift off this term to right side, the constant, which makes it minus 33. The second equation, 20x minus 9y, and shift off this minus 107 to right side, makes it plus 107. So you've got two equations in two variables. It looks like ax plus by is equal to c. They are simultaneous equations. You can use your calc and find out the variables. Just go to equation mode. In that you have to select the linear form, which is ax plus by equals to c. Select that option and enter the coefficients. The coefficients are 4, minus 5 and minus 33. The calc will ask you A1, B1 and C1 values. Enter A1 as 4, B1 as minus 5, C1 as minus 33. And then it will ask you A2, B2, C2. Enter A2 as 20, B2 as minus 9, C2 as 107. So once you enter this, press equals to, the calc will display you the answers of variables. The first answer displayed is 13, which corresponds to the first variable. The first variable here is x bar. And the second answer displayed on calc is 17, which corresponds to the second variable, which is y bar. So we got x bar and y bar. That's how you find x bar, y bar given a set of regression lines. And the second part is asking us to find out r. To find out r, you have to take the coefficients of x and y from the lines, because we have the formula r is equal to square root of coefficient of x into coefficient of y. This formula is used whenever you have two lines. The two lines are given here. So first thing what you should do is take back the lines, the first line and the second line, and find out x and y from that. So I have found y from this. You can find vice versa as well. You can find x from this, y from this. So I found y from this. So I'm shifting off this term to right side. Negative 5y becomes plus 5y. So 5y is equal to 4x plus 33. That's what we have written here. So from equation A we are finding y, and from equation B we are finding x. So 5y is equal to 4x plus 33, and y becomes 4 by 5x plus 33 by 5. 5 is shifted to the right side. So it's 4 by 5x plus 33 by 5. So we got y on x. We are trying to find y on x and x on y from the given equations. So from the second equation, we have this 20x is equal to 107 plus 9y. From that you find out x. X will be, just shift off your 20 to right side. So that would be 9 by 20 into y plus 107 by 20. So once you have the two lines, just pick the coefficients. So the coefficient of x here is 4 by 5, and the coefficient of y is 9 by 20. Just replace it here. Coefficient of x means the number associated with x, which is 4 by 5, and number associated with y is 9 by 20. So just substitute here and find the square root of this value from your calci. That turns out to be 0.6. So r is equal to 0.6 is the answer. That's how you find correlation coefficient when two lines are given. And make sure your r value always lies between -1 and +1. Only then your answer is correct. So 0.6, if you observe, it lies between -1 and +1. So the answer is correct. And here you should remember one more thing. You have found y from first one and x from second equation, and you've got r value within the range. If at all r is 1.6, it's outside the range, -1 to 1, then you should neglect this. It is wrong because it's outside the range. So go back and find out the reverse, that is x from first and y from second. I've not done that here because r value is within range. If r is not within the range, you have to interchange and find the variables. So we'll take up one more problem to understand that. Okay, this one. Two lines of regression are x plus 2y is equal to 5 and 2x plus 3y is equal to 8. Find mean of x and y, and also correlation coefficient between x and y. So two lines are given. You have to find mean of x and y. So it is x bar and y bar you should find first, and then correlation coefficient means r. So just now I said you, whenever two lines are given and is asking you to find x bar and y bar, you have to write x bar and y bar satisfy the given equations. So just replace your x as x bar and y as y bar. So this becomes x bar plus 2y bar equals to 5, and this becomes 2x bar plus 3y bar equals to 8. So once you substitute, they are simultaneous equations. Solve using your calci and find out the values of the variables. You have to go to equation mode and enter all the coefficients the way I taught in the first problem, and find out x bar and y bar. So x bar will be displayed on calci as 1 and y bar as 2. So we are done with the first subdivision. The second one is asking you to find r. To find r, as I said you, take the two lines, find x and y from these two equations. So I've taken the two lines, x plus 2y is equal to 5 and 2x plus 3y is equal to 8. I'm trying to find x in terms of y and y in terms of x. That is the lines x on y and y on x. So what is x from this? X is equal to 5 and 2y will be shifted to right side, makes it minus 2y. So x is equal to 5 minus 2y. And from the second one, you should find y. So I'll keep 3y here itself and shift off 2x this side. Makes it 3y is equal to 8 minus 2x. I need y. That will be 1/3 of 8 minus 2x. So once you have the two lines x on y and y on x, make use of the formula r is equal to square root of coefficient of x into coefficient of y. So what's the coefficient of x here? You have to see in the right hand side. The coefficient of x is present in the second line. If you observe, it is here. And the coefficient of that is -2 with a number outside, 1/3. You have to multiply this as well. So be careful, you should not leave this because it is 1/3 into 8 minus 1/3 into 2x. So the coefficient of x is -2 into 1/3, which is -2/3. The next you need is coefficient of y. What's the coefficient of y? It is -2. So just replace -2 and then multiply. So under the square root, you have to multiply 2/3 into 2, find out the value, it is 1.1547. And I have written negative here. I forgot to mention in the last problem. The sign is always assigned seeing the coefficient signs. What's the sign here? Minus and minus. If both the coefficient are minus, you have to write the sign as minus. That's a rule for the correlation coefficient. Please don't make it plus. Minus into minus is obvious plus, but the rule says minus into minus. If both the coefficients are minus, you have to write the sign as minus for the correlation coefficient. So going back to the problem which I taught you just now, if you observe here, it is plus and plus. So I have written plus. I have not mentioned that. It's plus into plus, so it is plus. And in this problem, it is minus into minus. So we should write minus. Minus sign should be assigned. Never you will get plus and minus as the coefficient. Coefficient signs will always be same. Either minus minus or plus plus. If both are negative, you should write negative. If both are positive, you should write positive. So once I've got the answer, I have to check whether this lies within the range. What is the range for R? It's between -1 and +1, whereas this is less than -1. That means it is outside the range. So this is wrong. So this should be altered now because we have got outside the range. That is because of the selection what we have taken here. So I should just reverse the selection. I had taken x from this and y from this, because of which r I've got outside the range. So our selection is wrong. We'll interchange it. We'll find y from this and x from this. So that's what I've written here. Therefore, choice 3 of regression line is incorrect. So write back the two given lines. I've written back the two lines given, and then find out the reverse. That is y from first one and x from the second one. So what is y from this? It is 5. Shift off your x this side. 5 minus x by 2. That's what we've written here. And find out x from this. 3y shifted this side. So it becomes 8 minus 3y divided by 2. So we got the two lines there, x and y. So now just pick the coefficient of x here. What's the coefficient? -1 into half, which is -1/2. Substitute in the formula, -1/2. Coefficient of y, -3 into half, which is -3/2. So both are negative. You have to first assign the sign negative. And then find out the rest from your calculus. Square root of half into 3/2 turns out to be 0.8660. So if you have done it correctly, you have to just verify whether it lies between -1 and +1. Yes, it is lying within -1 and +1. So this answer is correct. So that's the correlation coefficient whenever two lines are given. So this problem is important. We'll move on to the next kind of problem. Okay, show that if theta is the angle between the lines of regression, then tan theta equals to sigma x into sigma y by sigma x square plus sigma y square into 1 minus r square by r. So he wants you to find a relation for tan theta, and you want that relation to be this. So what is given? Theta is the angle between the lines of regression. So first write the two lines of regression, and theta will represent the angle between them. So in the solution part, what we'll write the two lines. So the two lines, if you remember, the line can be written as y is equal to mx plus c. That represents a straight line equation. So since two lines we are considering, I'll write it as y is equal to m1x plus c1, where m1 represents slope of this line. Y is equal to m2x plus c2, where m2 represents the slope of the second line. So once you have written the two lines, if you remember in your 12th standard or 11th standard, you have learned how to write tan theta in terms of slopes. That's a relation for tan theta, which is m2 minus m1 by 1 plus m1 into m2. So that's the angle between the lines given by tan theta equals to m2 minus m1 by 1 plus m1 m2, where m1 and m2 are slopes. That we have represented here. So this is the formula for tan theta in terms of slopes. We'll make use of this and try to derive what we need. So I need in terms of R and sigma x. So R and sigma x, you know, you have it in your lines of regression. So refer back that. So lines of regression are given by y on x is this, that is y minus y bar is equal to R into sigma y by sigma x into x minus x bar. This we have learned in the last video. And one more line, x on y is given by x minus x bar is equal to R sigma x by sigma y into y minus y bar. And try to write both the line equation in this form, standard form, which is y is equal to mx plus c. If you observe here, it's already in standard form, y minus some constant. So it is y is equal to m, some constant, into x plus c. So don't change your first equation. Check if your second line also is in the similar way. So we have written this here. We don't have y in the left hand side. So try to bring y to the left hand side. I mark it as equation 2. From this, I'll find y minus y bar. So what is y minus y bar? Shift this term to left side. So this will become reciprocal. So I'm shifting it here. It becomes sigma y by r sigma x into x minus x bar. So now it's in the form y is equal to mx plus c. Mark it as equation 3. So the two lines, equation 1 and equation 3, are of this form. So what you can conclude, you can say that this represents m1 because it is like y is equal to mx plus c. So coefficient of x is always the slope. In your line equation, coefficient of x is always the slope. So what is the coefficient of x here? The coefficient of x here is r sigma y by sigma x. That represents m1, the first slope. And coming to this second line, what's the coefficient of x? Sigma y by r sigma x. That represents m2. That's what I've written here. From 1 and 3, m1 is r sigma y by sigma x, and m2 is sigma y by r sigma x. So once you have the two slopes, m1 and m2, what you can do is you can just go back and replace in your tan theta relation. So this is tan theta. In this relation, you can just replace what is m1 and m2. So we'll replace it here. Tan theta equals to m2 minus m1 by 1 plus m1 into m2. So I've written it here. Tan theta is equal to m2. m2 is this one. Replace it here. Sigma y by r sigma x minus m1 r sigma y by sigma x whole divided by 1 plus m1 into m2. So take the product of these two, r sigma y by sigma x into sigma y by r sigma x. So once you have substituted, try to simplify and get the relation the way he has asked in the question. So how to simplify this? If you observe in the numerator, you have something common there. Sigma y by sigma x is common. Take it outside. Sigma y by sigma x. What is left out here? 1 by r. So 1 by r is written here. Minus. What is left out here? R. Divided by, if you observe in denominator, r gets cancelled. And left out is 1 plus sigma y into sigma y is sigma y square. Sigma x into sigma x is sigma x square. And then further, we'll check if we can simplify it further. Okay. Numerator, I've written as it is, the first term sigma y by sigma x. And the inside term, if you observe, we can take out LCM. LCM is r. Nothing is there here, means 1. So 1 and r LCM is r. And this gets cross multiplied, which is 1 minus r square whole divided by the same thing in denominator I can do. I can take the LCM, which is sigma x square, I've written sigma x square, cross multiply this. So 1 into sigma x square is sigma x square plus sigma y square. So denominator sigma x get cancelled. So 1 sigma x and 1 sigma x have cancelled. And the left out, you can just write it as it is. So this fraction goes to numerator and becomes reciprocal. So that is sigma x into sigma y divided by sigma x square plus sigma y square. That's what we've done here. So sigma x into sigma y divided by sigma x square plus sigma y square. And this as it is, 1 minus r square by r. So that's a relation which is asking. If you want to recheck it, see. It's the same relation is asking. We have got the relation. So that's how we can find tan theta in terms of sigma x and r. This is also an important derivation. Moving on to the last problem in this session. In a bivariate distribution, bivariate, bi means two, variate means variables, two variables. In a bivariate distribution, sigma x is equal to sigma y and the angle between the regression lines is tan inverse 3. Find the correlation coefficient. So what he has given sigma x is same as sigma y and the angle he has given, which is theta, between the lines as tan inverse 3. So theta is equal to tan inverse 3 and he wants you to find r. So whenever he has given the angle, make use of the derivation which we learned just now. Make use of that formula, which is tan theta is equal to sigma x sigma y by sigma x square plus sigma y square into 1 minus r square by r. Find out r from this. You have all the other tan theta is given and sigma x is same as sigma y. You can find out r from this relation. So we'll see how we can find it. What is given? Theta. Theta angle is given here. Angle between the regression lines is tan inverse 3. So theta is equal to tan inverse 3. So you can shift off tan inverse to left side. It becomes tan theta. So tan theta is equal to 3. And sigma x is equal to sigma y is given. So sigma x is equal to sigma y. Make use of these two in your formula. So instead of tan theta, I'm replacing it by 3 and sigma x as it is. And we know sigma y is same as sigma x. It's given in your problem. So instead of sigma y, replace it as sigma x. So sigma x into sigma x is sigma x square divided by sigma x square as it is. Instead of sigma y, replace it by sigma x. So it is sigma x square plus sigma x square, which is 2 sigma x square into this as it is, 1 minus r square by r. So sigma x square will get cancelled. This cross multiply it, you have 2r here. Just shift it to left side, becomes 2r into 3, which is 6r is equal to 1 minus r square. So we got the equation. If you observe, it's a quadratic equation. You can rearrange it. Shift all the terms to left side. So minus r square will become plus r square, plus 6r, and 1 becomes minus 1 equals to 0. It looks like ax square plus bx plus c. It's a quadratic equation in the variable r. So you can make use of a scientific calci. I've solved it manually here. You can make use of scientific calci. Go to equation mode, enter the a, b, c values. Go to equation mode, select the quadratic form ax square plus bx plus c. The calci will ask you the values of a, b, and c. So a is 1 here, b is 6, and c is minus 1. So enter those values and give equals to. The calci will display the answer as 0.1623 and minus 6.1623. Two answers it will display because it's a quadratic equation. But we need a single value for r. R is a single value. We have to select which one is correct. So which one is correct here? This lies between minus 1 and plus 1. Whereas this is outside the range minus 1 and plus 1. It's less than minus 1. So this one is incorrect. And the correct answer is r is equal to 0.1623. So that's how you find r value for this given problem. So that completes the session. Hope the session was useful. Thank you all.